Let's commit this session to the Lord. Father God in heaven, we want to thank you for this time. We want to thank you, Lord, for the gift of life. We want to thank you for yet another opportunity when we come together to learn from each other. We thank you for all those that have been able to put aside some time to join into this session. We ask you, Father, that you open up our hearts, our minds, to be able to receive whatever there will be for us to learn. We commit Professor Padhu into your hands, that Lord, you guide him, that Lord, you enable him, that Lord, you give him the favor, and that Lord, as he speaks with us, we will be able to benefit a lot that is intended to improve our teaching and learning in this country. We pray for all those within Uganda and those beyond Uganda that have signed in. We pray for all the schools and their head teachers. We pray for everybody that has been able to make this possible. We thank you, Lord, for all the sponsors. We thank you for Mr. Dungu and your team for making it an effort for us to be able to come together and have a conversation on how best we can improve STEM education in our country and in the African continent. We thank you, Father. For this we've prayed in Jesus' name. Amen.
Amen. Thank you so much, Caroline. We are really very happy to have you, and we want also to welcome you for this session. Thank you so much for joining. Allow me now to welcome the principal in charge of secondary schools at the Ministry of Education and Sports in Uganda. Mr. Ronald, you're most welcome.
Thank you, Mr. Kaziva, and thank you everyone who is joining this afternoon. Thank you, Professor Padhu, for coming yet again. Professor Padhu was with us last month in July, on the first Thursday of July. He is back here on the first Thursday of August. He will be here again on the first Thursday of September, on the first Thursday of October, and on the first Thursday of November. And that gives us a series of talks, a series of workshops, a series of meetings, a series of coming together to talk about how to deliver education better. The topic he's handling is a critical topic, like he will take us through, because we are into the new curriculum and it is very important. Even those who may not be teaching as yet senior 1 up to senior 3, and we shall find you at A level later, the curriculum will change and the process has started. So it is very important that you listen in and be able to participate well when the curriculum changes at the different levels. I bring you greetings from the First Lady, Minister of Education, the Permanent Secretary, Ministry of Education. I also bring you greetings from the Commissioner, Government Secondary Education, and those who are coming from the private sector, the Commissioner from the Private Secondary Schools Department. I also bring you greetings from all of us at the Ministry of Education. We are excited to be joining in, to be listening in, but most importantly, for us to get Professor Padhu to contribute to the transformation of education in this country. Going forward, and we have discussed with Professor Padhu, how we can make this a continuous professional development course. So in future, Professor Padhu will be coming up together with the ministry, a particular course that we shall undertake probably next year. This is a pilot to see what is possible. And we should have certification at the end of these courses. And maybe we'll have Professor Padhu visiting for a week so that we meet physically with him, but all that will be planned if these pilots go on well. So I want to thank those who were here last time and you're back. because I know the schedules are so tight, but I also know that we have to migrate many of our friends to the online sessions so that we can learn together across the districts. I will request that whoever is on the call, you indicate the school and district where you are based. It would be very important for us to know the schools and the districts where you are based. I don't want to use up a lot of your time because today is a learning day. I'll be here learning with you, and I hope that we shall get many more friends joining us along the way. With that, I want to wish everybody a good afternoon, and I declare this session open. Thank you, Mr. Kaziva, and your team. Over to you, Mr. Kaziva.
Thank you so much, Principal, for the opening remarks. Allow me now to welcome Professor Padhu to take us through the presentation. Professor, you're most welcome.
Wonderful. Good afternoon. It's early morning here in the East Coast of the United States. But I'm so happy to be back here. And as Mr. Dongo was talking about, hopefully the series that we have started here will start to become a pathway for what may be referred to as reskilling or upskilling. So, if you are already a STEM teacher, you're learning more, then you're upskilling. If you're not a STEM teacher and you're learning something new, then you're reskilling. And so this idea of reskilling and upskilling is becoming very popular. And the incentives that go with the reskilling and upskilling is something that I'm working with many ministries. In fact, next week, I will be in South America to work with the Ministry of Education there to talk about exactly similar ideas. We are in a world where we have to upgrade ourselves. Now, that upgrading may be in your own subject, say mathematics, or you're a mathematics teacher and you want to actually learn about science and how you can bring science into your curriculum, then you're actually reskilling. And so it's very important that integration, is always happening in the curriculum. And STEM is a way to integrate. And again, STEM is not a subject. I would like to clarify this. Many ministries, many people that I met, they think STEM is a subject. STEM is not a subject. STEM is a way of thinking. It's a way of integrating. It's a way of communicating with each other. And if you are a mathematics teacher and you only teach algebra or only teach geometry and you don't want to learn about, where the algebra will be used, then you're not doing justice to the students. So it's always, the algebra that you're teaching or the quadratic equations you may be teaching is just the what and the how. So, but you also have to teach the why you're teaching it. So because the students are asking for, why are you teaching me quadratic equations? Why are you teaching me, cell biology? Why should I learn this? So the why is very, very important. As teachers and educators and Ministry of Education and all that, we focus too much on the what and the how. We need to start focusing on the why we are doing this. So I hope you will take that initial part of the message as something that we can all enhance ourselves on. So thank you again for this opportunity to come back, and we will see again how much we do. And in the last session, we talked about project-based learning. In this session, I want to build upon what we did last time and present to you a different problem-solving frameworks that are associated with STEM and how you can use that in your classrooms. Okay, and again, these 4 sessions are very condensed, and we may open this up. Maybe when I come there, hopefully we will actually do it as day-long sessions for a whole week and things like that. It'll be like an institute where you really engage. But I've given some ideas on how you can actually use some of the ideas that I'm talking about back into your classrooms. So thank you again. Thank you, Carolyn, for that wonderful prayer, and also for the Ronald for the invitation again. So several of you already asked me about like my contacts and how do you connect with me and all that. So I'm gonna on the chat throw my Twitter and LinkedIn. Please feel free to just connect with me, and then you can definitely be in touch, and you can see lots of I regularly post messages, and you can see the programs and initiatives that I'm doing, and so you can be connected as well. So just like I started in the last session, I want you to come out of your comfort zone. So the mind is like a parachute, and it will only work if it is opened. So what I would like you to do is, whenever I say, please type on the chat, please type on the chat. Okay. So, so I'm going to start off with, always a warm-up. If you remember, I had a warm-up last time where I showed you pictures of 2 sets of dogs, and I asked you which dog grew more. And it was very clear that the crowd did not agree. Some of you said dog 1, some of you said dog 2, and then some of you said both are the same. And that led to a really nice discussion of how counting or addition, multiplication, operations happens across grade levels. So it's very, very important. So we talked about learning progressions, and that led to project-based learning later on and all that. So today, I'm going to prompt what I'm going to teach next in September, but I want to just go ahead and start that already. So on the chat, I see all of you are saying which district you're from. This is wonderful. But I'd like you to take a second and type on the chat. Who do you see on the chat? Anyone recognize this person on the chat? Type on the chat. Money. Okay. So I see. So you're all very good. I see lots of good students listening to me very carefully. And Ronald, so lots of you are immediately typing money. Very good. And wearing a red shirt. So Stephen made one more thing. So let me tell you the strategy that I'm using. I'll bring back in the next session. It's called, and I'm going to type it on the chat. It's called a very important thing called notice and wonder. So many of you noticed it's money. Stephen started wondering, he actually said he noticed a little more. He's wearing a red t-shirt. Any wondering that you're thinking here? So let me ask you, let me show you one more slide and ask you about wondering. This is not, this is an older picture. You know that he got traded. So this is an older picture, 2016. But what are you wondering now? So the first tool today is a pedagogical practice called notice and wonder. So what are you noticing? You noticed it was Mane. What are you wondering now on the screen? Why is he excited? Very good. This picture is very good. Why is he excited? Maybe he just made a goal, right? That's a good one, Caroline. Why is he excited? So you ask questions. What I'm doing today with you, you're going to do it with your students, because you got to keep your students talking. Now, what is a wonder when I show you the screen? What's a wonder in your head? How much does he earn? Yes, that's right. I heard some nice things about him compared to other sportsmen. Apparently, he supports his village. He gives certain euros to everybody in the village, unlike a lot of other people ever. So he's excited. Okay, so you're all noticing he's excited, but now I'm showing you a slide with numbers. What are you wondering? Any wonders that you're doing? What is his future plans in sporting? Yes, good. That's a good idea. He's already got traded. And but look at the screen that I'm showing, and any wondering with the numbers, his performance records. Exactly, Eli. Okay. What anybody that knows soccer, are you learning something from this data set or data that you see? Or anybody that has no clue on soccer, this probably is like completely Greek to you. Is that correct? Say yes if it is Greek to you. These numbers make no sense to me. Yes or no? Trending and in good position. So some of you, somebody is actually very particular, 7.07 to, somebody noticed the rating 7.07 to, so he improved. That seems to be an interesting one. I'm not getting much sense. So Caroline, that's very good. You are going to have students that will know soccer. You will have students that have no idea what is going on here. So I wanted to make sure that as a teacher, you address both students, okay? So, and I'm wondering why you picked him. Very nice question, Sandra. So I actually wanted to pick a basketball player, one of my favorite players, but I decided to do soccer because, you know, Africa, I think, and then I know Africa is now big on cricket also. So it was very tough for me to select, but I realized that soccer is the most exciting thing. When I was in Uganda last time, it was like the World Cup, and there was lots of, you know, it was very clear you guys like soccer as one of the most, I hope you all agree with me that it's one of the most popular sports. What is the meaning of appearance? So I want to actually ask you to focus on Caroline's question, because she's asking some very interesting questions like, what does appearance mean? Is it like dressing up? Because these numbers don't mean anything, right? So this is one way to present data. So I'm already prompting what I'm going to be bringing back in September. September is going to be data science, okay? Now, I'm going to show you another thing. This is the heat map of Mane touching the ball in Premier League for Liverpool, you know, all the way from 2017-18, the first two pictures, I forgot to put it here. So this is like 17-18, 18-19, 19-20, 20-21. This is all his pictures of a heat map of how he's hitting the balls. Now tell me what you actually observe. Go ahead and try all the things that come to your mind. Just look at the picture and tell me what comes to your mind. Even people that don't know soccer can actually say something about these pictures. A heat map is where, like, you know, the more red you see, the more hotter he gets. He's bad at helping the team defend. Okay, I don't know, Kawesi, if you're making that observation from the pictures. Very nice. Komakes is saying mostly on the side of the pitch. Very, very interesting observation. He's always shooting. Which side do you see? Do you see where he's shooting from usually? He's attacking more than defending. Very good observation. He walks a lot. Okay, a lot of attack. There is a particular spot he shoots from. He's most times in the opponent's half near the goal. Look at the amount of observation. Is goal hungry? Exactly. He's right there, right next to the goal. So Caroline is saying, but can't tell what it means, right? So, but at least it's starting to make sense than the numbers that I showed you before. So it's like, instead of this, you know, instead of showing something like this, I show you a picture, the students start talking more. He improved in his passes. So it's amazing how many more observations I got than this. So it turns out this idea of notice and wonder gets students talking at the beginning of the class. So use a nice picture and get them to talk. It need not be STEM. It could be, you know, President Mandela, Nelson Mandela, and you could show the picture of President Nelson Mandela and say, talk about the President Mandela. Maybe they'll talk about apartheid. Maybe they'll talk about, you know, something, how he loved cricket. I know, maybe they'll talk about different things. So it's about showing a picture and asking them, what do you notice and what do you wonder? It's a very powerful pedagogical move that you should do. Doesn't matter what grade you're teaching, it's a very useful thing to do. Now, I want you to observe many of the things that you guys said. Mane dominated on the left side of the pitch. Somebody observed that. Mane's favorite spot to receive the ball is the middle third of the attacking half. I saw somebody said that. His shot maps remarkably similar over the time span. He seems to be very similar, shooting very similar, and he took more shots in 2021 than you know, before. because the more red it is, the more shots it is, right? So what you just made the students do is what is called as data communication. So in September, I will introduce you to data science education, something I want to build in Uganda with the Ministry of Education. The power of data science is the power of visualization. And really, this age kids, they want to really look at data and make decisions and things like that. So it's a very important thing that I want to introduce you to, but it's for later. So that's the initial part of the talk. Now, if you remember, in the last time, we talked about a very useful talk. So I'll go through some things that we did last time, something called CODAP, Common Online Data Analysis Platform. And let me give you a very quick update on CODAP again. So CEO, and I'm not going to spend a whole lot of time, but just to give you, those of you, if you're joining for the first time, you didn't come last time, CODAP is an online software which allows you to do some simple visualization, just like what we saw, graphs. You can start by clicking on Launch CODAP. You could bring your own document if you have an Excel file with data. If not, you could take a document that's already there. I'm going to take an example of mammals, and I'm going to open this. You don't have to do it with me right now, but you can do this later. And you could see that this is a list of 27 animals. And it talks about the name of the mammal, African elephant to cheetah. It tells you the order, it tells you the lifespan, tells you the height, it tells you the mass, sleeping time, speed, habitat, diet it eats. Is it a meat eater and all that stuff? So next time, again, I will tell you how teachers should be using data sets like this. First, you ask the students to make a hypothesis. So a hypothesis, for those of you that came last time and those of you that did not come, can you type a hypothesis on the chat? Like, what are you wondering about? A hypothesis. There's a data set that was given to you. Give me a hypothesis. What would be a hypothesis? A hypothesis is, if this, I think if this, then this, right? I think if this, then that. Anyone wants to make a hypothesis? On the chat, you can type, like, I think if the animal is, taller, there it is. Stephen is making, animal has a big mass, runs fast. That's Stephen's prediction. Let's check. So I have a graph here. I can actually click on the graph and the graph starts to form here. And all these are the animals. It's so nice that if I click on something here, it actually is so dynamic that it takes you to the data immediately. So that's about the lion. Lion is right here. So let's think about an animal with a big mass. So I'm going to take the mass and I'm going to move it to the x-axis, and it tells you all the animals. It arranges all the animals according to mass. So let's see who's the heaviest. The African elephant is the heaviest. And then the Asian elephant, and then the killer whale is heavy and all that stuff. So that's the mass. But Stephen was wondering, let me go back to Stephen's hypothesis. Stephen said a mammal that has big mass runs fast. Okay, so what I'm going to do now is I'm going to take the fast, which is the speed, and put it on the y-axis. I get something like this. Now, do you think it is a linear? That is, it's the more the mass, the faster it goes. What do you think? Yes or no on the chat? It was a good guess, but I have to unfortunately disappoint Stephen. Or Stephen does the experiment and notices that, wait, a cheetah is only 50 kilograms, but it runs the fastest. So so maybe the hypothesis is incorrect, which is okay, because he did some experiments and he finds the lion is 250, but then he sees like an African elephant is like 7,000 that only runs at 40 kilometers per hour. Great. So you notice that it's not a linear pattern, or the scatter plot is not linear. So it's okay, but the students at least tried, right? And Sirike, the name of the app is called CODAP. And I'm going to be teaching this next time in detail. But just wanted to give you an idea today, again, because I introduced it last time. So let's try somebody else's. So I think I saw, yeah, CODAP, CODAP. Let's try another one. Maybe I think like maybe the mass, the one that is the heaviest is probably the tallest. And I'm going to make a prediction. I saw somebody, oh, this is not linear, but at least has that trend. So yes, it doesn't have a relationship, but this graph is different from the last graph. So let's see if there is a line. So you see this ruler button here. So I'm going to click on the ruler button and then there is a line. And I can actually draw the line and see if this is a linear trend. It also tells me, height and mass. This is y is equal to mx plus b, which is basically the point slope form for the equation of a line, or actually slope intercept form. Sorry, slope intercept, y is equal to mx plus b. M is in this case, the b, and the m has to do with, the slope of the line is m and b is the intercept. So you can allow the students to play with the line, whose line is the best one. And then you can tell them about the least squares line or the best fit line. And the best fit line is the green line. It tells you R squared is regression. So welcome to linear regression. So you understand how I introduced a mathematics concept after telling the problem. So please don't always start with the mathematics and then tell the students the problem. Start with the problem and bring the mathematics out. My first message today. Okay. Too many educators are always teaching, here is the STEM, go solve the problem. Here is the mathematics, go solve the problem. Most of the time, the kids don't get to play with the problem. So please upgrade your philosophies of teaching to, here is the problem. Let's find the mathematics to do it. Let's find the physics to do it. Let's find the STEM to do it, and so on. So reverse the idea, then you will become a better educator. Okay. So this is about linear regression, and you can talk about lots of things from there. What is R squared? What is y is equal to mx plus b, and all that stuff. And we also talked about, you can talk about, these are all like numerical, but then there is categorical variable like habitat and diet. So if I take a graph and I take the word diet and put it on the x-axis, you notice immediately it says all the mammals that are eating both, all the ones that are eating meat, only all the ones that are eating plants. Now I want to know which ones, of these are, for example, I can bring habitat in on the y-axis. Now immediately it splits this into land, water, and both meat. And this, so you can see the type of power of data visualizations that you can create. Now this is just the surface. Okay. When we do data science later, you will see the power of data science. Now this is what the current, job trends, everybody's looking for, getting kids excited about data. So this is an example of that. Okay, let's go back to the top. So we introduced this last time. We also introduced another tool called Jamboard, Google Jamboard, where people can collaborate. And you can actually, you all actually came up with these ideas. This is not my ideas. This is your ideas. You all typed a lot of interesting things because I asked a question, what are important competencies and skills needed for problem solving in science, mathematics, and ICT? And you said, different things. And what I did was I grouped all the ideas that you said, and clearly they came into some boxes. So some of you focused on technology. Some of you focused on lifelong learning skills like critical thinking and creativity. Some of you focused on like how to teach it. And some of you focused on, again, just, basic coordination skills and things like that. So my job as a teacher there was just to group things and group ideas, common ideas between people. And this is what came out. This is your work, okay, from last session. So then we talked about crude approximations that you should learn how to make and I introduced to you the Fermi approach. And we talked about how many air conditioners or repairmen are in Uganda, and you all gave me an estimate, and then I walked through how you can actually calculate it. So simple idea. So we talked about the Fermi problem. We talked about computational thinking, how Fermi problem motivates computation, how it allows students to break down problems, problem decomposition, how it helps them to actually recognize patterns, how it helps them to think algorithmically, and how to abstract from computation. Now, these four fundamental pillars are a part of what is called as computational thinking. And again, I'll bring this back next month because this will form the pillars for data science. You know, if you want to have children think much earlier, you got to go into the Uganda curriculum and add computational thinking early on. And this is the type of thing I'm advising ministries on how to do it. India released something called the National Education Plan 2020. Computational thinking is all over the plan. They are actually bringing it in 4th grade. They're bringing it in 8th grade. They're bringing it in 12th grade. But the question is, you don't want to just throw these things into a policy document. You need to know what it means. So next month, I'll tell you what it means more. But Fermi was an example of computational thinking. We also talked about an instructional approach called 5Es, which is how do you start by engaging the student? How do you then have them explore? How do you have them explain their thinking? How do you have them elaborate on their thinking? And how do you have them evaluate each other? It's not about you evaluating the students. It's about students evaluating each other. Peer evaluation, very powerful. And how do you put a 5Es into your lesson plan? That will be the 4th session, creating a lesson plan. Now, so we talked about this. We also talked about how do you connect all this to a context. And the context we talked about was the United Nations Sustainable Development Goals. What is the math behind hunger? What is the math? What is the science behind energy? And so you need to be able to connect to a context. It's not that United Nations just made up these things, but the challenge for educators and education ministries is how do you connect something like hunger to a fraction problem in a 4th grade textbook? Many countries are struggling. They don't know how to do it. You know, you have the goals at one level and you have the books at another level and the teaching at another level and the curriculum at another level, and somebody else is, and the students are wondering why are these not connected? I mean, why is there? So we are doing injustice to the students. I mean, starting from the United Nations to the ministries, to the teachers. If you do not connect the dots, the children are failing. We are failing the children. Okay, so it's very important. It's one thing to create a policy in the ministry. It's one thing to create United Nations at a higher global framework. It's one thing to create something else. If you do not connect the dots, then we are all failing. It's very important. So just it's not like something to publish in a paper, but it's something to really use it, because the children these days want to solve a problem in hunger. They want to solve peace and justice. So give them the opportunity to teach. The problem is you and me were not trained this way. We were trained in a very traditional way. So we end up teaching the way we were taught. But we need to be starting to teach the way students want us to teach. So it's very important. So that's another philosophy I want to actually make sure you all understand. Then connected to something real, like for example, water consumption in Uganda, for example, or water supply, or water distribution, or water sanitation. There are so many challenges. Bring the mathematics in. Distribution is percentages, pie charts, and talk about those things, collecting, data collection, and so on. So how do you connect it to a specific goal, and how the goal has many targets and all that stuff? So I gave you an example last time, what happens when you put vinegar in egg. And many of you did not know. Well, it turns out that calcium carbonate is the shell of the egg. And, it combines with acetic acid to actually produce, reaction, and it breaks the shell. And once it breaks the shell, the water from outside, because water molecules are more outside, they go inside the egg and the egg becomes bigger. And so the egg starts, so this process is called osmosis. So notice that we brought like a science concept using a simple hands-on learning. And then we can connect to what is acidic, what is basic using pH scale. Also notice I used a chemical reaction here. So based on who you're teaching, you can actually bring different ideas in terms of, say, balancing the equation, or teaching them chemistry and teaching them something real world impact. Now, why is this real world impact? Context. Because we are throwing so much plastic in the ocean, and even carbon dioxide, 1/3 of them goes inside the water, and they actually form this acid. The same thing happens. It's kind of, think of it as vinegar, and it's actually falling on top of these creatures that have shells. So that's why I chose the egg experiment. And so the shells break, and the animals die. And, guess who eats the animals? The fish. And guess who eats the fish? The tasty Nile tilapias, right? So what do you think the tilapias are eating? Those little creatures that we ended up somehow killing from the environment. So it's very important for you all to understand that we are responsible for the environment. So this is the context I was telling you about. And how do you go back and bring STEM inside? That's project-based learning. Okay, so it's very important to give the students a voice and choice on real problems. So you could take real challenges from Uganda and have the students engage in the mathematics, in the science, technology, and so on. So I'm watching time again, so I'm going to do this very quickly. I taught you notice and wonder. I want to teach you another one called what do you know, what do you want to know, and what did you learn? So this is a very powerful strategy when teachers are teaching, let's say, fractions. So they ask the children, every child is given a sheet like this. The sheet is divided into 3 parts. They say, what do you know about fractions? The children are saying, well, I know 2 by 4, 2 divided by 4 is written like this, 3 divided by 5 is written like this. So they are drawing. So this kid is definitely visual. And then what do you want to know? The kid is saying, how do we subtract fractions or add fractions? How do we multiply fractions? Now notice that what do you learn? What did you learn is empty. This is true because before the class, you ask them, what did you know and what did you want to know? And then you teach the class and then give them the sheet again and ask them, what did you learn? This is the whole idea, okay? Now, you could do it in science class. For example, before the class, you can ask them about dolphins. Dolphins live in the ocean. Dolphins can do tricks. Dolphins are smart. Dolphins need to breathe air. Are dolphins fish? Or what do dolphins eat? Or, do they give babies? Do they lay eggs? We don't know. So the students write these 2 things, then the teacher teaches, and then the students are given the sheets back, and then they write down what they learned. Dolphins are mammals. They are not fish. Dolphins communicate. This is a very powerful idea called KWL. Now, how do you actually use this in you can use this for any idea for your classroom, anything that you're teaching, agriculture or whatever it is. So I want to play this real-time data collection with you all for one topic, and let's do it for about 3 minutes. It's implications of AI technologies in teaching and learning. You know that ChatGPT, Mr. ChatGPT is here. All these guys are here. So you are all wondering, like, is it going to take my job away? Is it going to do this? So I want you to work with me on what do you know, what do you want to know, and what did you learn? So in order to do that, I'm going to give you a website, which is just a Google slide. And you will see 3 tables like this. And I want you to start typing. So I want to go to that sheet right here. You're going to see this sheet and come to the sheet. Do not change the table. Just go into the table and start typing. And there are 4 pages here. So you have many pages. You can go, if somebody is typing on a certain cell, try not to type on the same thing. Go into something else and type, or go to another page and type. Okay. I'm going to put the link on the website. Those of you that are able to access today, go ahead, click on the link, and I will know if you're coming into the link. Let's go ahead and come into this link where I put it on the chat. Come into the link, and I want you to think, just type the first 2 columns there. I see you all coming in. Very good. Go into the 2nd page or the 3rd page. Just say, what do you know? What do you want to know about AI technologies in teaching and learning? What do you want to know? Do you want to know if it's going to take your job away? Do you want to know how to use it in the classroom? Go ahead. Okay, good. What do you know? I see that somebody is typing. They are just machines. Don't type, what did you, if you learn something, go ahead and type. But at this point, We are only typing what did we want to know. And but if you learned something already, go ahead and type. I would like to know if you learned something already. So somebody's saying they're just machines, nothing else. Somebody's saying, how do you think like a human being? Very good question. Yes, that's very important in teaching.
Professor,
yes.
The members are typing in the same cell, so
yes.
they are deleting.
Oh, they can go to the next page. So you can go to the next page. So you don't have to type on the same cell. You can, there are so many cells. I have 4 pages for you. Go ahead and type wherever you want. You can go to yes, keep typing. I'm going to wait for you. So I'm reading as you're typing. So if there is no space in the cell, go to the next cell, next page. So this is ICT in action, real time. Imagine doing this in your classroom and the children will be so excited to give their viewpoints, right? So this is how you collect data. So we are collecting this. So can it draw diagrams? Very interesting question. Very good. So you're wondering, do you want to know that? So it's interesting. None of you are afraid of AI, looks like. You're not saying like when I did this at another place, they said, it's going to take away my job. It's, I am afraid of AI. People wrote all sorts of things. And it seems like Uganda, you guys are not concerned or you're not afraid of what is coming. Good. What is AI? Very good question. Artificial intelligence. Very good. So then you have how will they conduct guidance and counseling? Very good question. It's not a human. It's a and then here I'm seeing, can it draw diagrams? What did you know again? And again, you can go to the 3rd page. I don't know anything. Okay, good. That's good. If you don't know there's something, that's completely okay. I want to know how to use AI in education. Very good. All these different wonderful ideas. Okay. So you can keep typing. I want to go back to the talk, but what I did just now is real-time engagement. Okay. I engaged you all real time and you all typed very nicely. I'm going to just move this thing from this page to the previous page right here. So, right here. Sorry. I'm going to remove it right here. So I'm just populating everything on the same page. And so good. You can keep typing. It helps us save time. Somebody actually is talking about the positive points. It's interesting. None of you talked about negative things about AI. That's very, very interesting. I'm going to leave this sheet open until next month. So I want you to type as much as possible. And I'm going to make more pages. I'm going to duplicate pages so that you guys can type away. And Ronald and Stephen, you guys can ask people to type it because I do want to bring this back next time. Okay. So at least you learned another tool, Google Slides, and how to actually crowdsource data real time. Okay. So this is very important. Coming back to the talk again. So from this point on, it is going to be a lot of getting you to think about frameworks, which is the core of the talk today. So the first important framework that I want, so you can take notes from here, and of course, the video is recorded. You can always go back and see. The first and foremost is something that you all may be familiar with. This is in 1956, Benjamin Bloom introduced this idea called the Bloom's taxonomy. You all probably are very familiar with this. So Benjamin Bloom, he collaborated with a bunch of people and came up with what is called as a taxonomy for educational objectives. Now, okay, access it from the phone. You just need to click on the Google link. I don't know, Mark, if you're still asking about the Google Slides, but we can do that later. Let me move on with the talk. So Benjamin Bloom introduced this in 6 categories: knowledge, comprehension, application, analysis, synthesis, and evaluation. So these categories was presented as skills and abilities, with the understanding that knowledge was the necessary precondition to putting these skills and abilities into practice. But then this was like the original version of it. So where, knowledge is like recalling something, methods, processes. Comprehension was referring to an understanding. Application is like using abstraction from particular situations. Analysis is like breaking down the communication. And synthesis is putting it all together. And evaluation is like passing a judgment, let's say, about your work. Now, later on, a group of other people came together, especially Anderson and other people, and they revised this. and from what you see on the left as Bloom's taxonomy to what you see on the right. Now today, this on the right is what is being used. Now, can someone type on the chat, what were some of the immediate changes that you see from 1956 Bloom's taxonomy to 2001 Bloom's taxonomy? On the chat, what are the things that you see from the original Bloom's taxonomy to the one that everybody uses now? On the chat. What do you recognize from the, what do you wonder? Change in the levels, very good. So Stephen sees some change in the levels. We'll talk about it. Specifically, if you notice, one of the things, evaluation is at the top of the pyramid here, but create is at the top of the pyramid. Evaluate has been moved to the second row. So that was changed, exactly right. The top two levels were interchanged. What else? Another very important thing, very, very important thing. Synthesis, synthesis kind of is the create. It was not removed, it was replaced by create. Yes, so instead of knowledge, it was more of remember. Comprehension was changed into understand. Application was apply, that stayed. Analysis also stayed. Now, what I want you to also understand is I could not know how to use my phone, okay, to know how long systems work as a teacher. We can address that later on, Birungi. I'm not sure exactly what you're asking. Okay, so so the idea is that, as some of you pointed out, yes, the first two levels were interchanged, and nouns were changed to verbs. I don't know if you observed that. So a whole, when the Bloom's taxonomy changed, you know, they tried to use action verbs to actually, and then the problem with the ministries of education is, and the exam inspection is, they take this and use the whole thing as an examination tool. I don't know why people do this in the ministries. They just say, oh, did the student remember? 10 points. Did the student understand? 10 points. Did the student apply? 20 points. Did the student analyze? 20 points. You know, the problem is somebody presents you a framework and you immediately turn it into a rubric. Another big challenge, this is for the Ministry of Education, hopefully you're hearing me, is not to turn somebody's framework into your examination rubrics, because again, you're hurting the child. Okay, so just because somebody came up with this doesn't make your ministry, you know, create a rubric based on this. You got to really study, because I've seen this in several places using this as a rubric, which is unfortunate because it just is easy to grade. So let's just use these as action verbs, right? But you got to understand what those action verbs really mean, you know. And the question is, should this be a pyramid, or should remember be inside understand? Should understand then be inside apply? Should apply be inside analyze? So I like this type of a Bloom's rather than a pyramid, because a pyramid says like, I'm above you, you are above somebody else. So it's like this whole hierarchy, which sometimes is not the greatest thing in the world. Okay, so it's more like a dictatorship type approach. So you want to really think how one is inside the other. So, but then you want to break down all those simple words like remember. What does that mean? Well, define. Did the student define? Did the student list? Did the student memorize? And so on. Exactly, Caroline. Pyramid gives the impression that create is lesson. Exactly. And you're totally right. Also, the size of the pyramid, you're absolutely right, because create is the whole thing. The kid is creating a product at the end of the day. That's the power of this whole thing. But people misinterpret this. And so you got to really go into these words, design. Did the student design? Did the student construct something? Did the student develop something? And so on. So that's the first framework that I wanted to make sure you all understand and use properly. Now, as you see the picture, Bloom's taxonomy is like this pyramid model. It's like you are below, I am above. I don't like models like that because, you know, so please carefully use Bloom's taxonomy, you know. So Each one of them has several action words. Understand what the student is doing. Don't just give a 0 if you don't know what the student is doing and all that. So that's the first thing. Fink came up with a better, I would say, version of Bloom's taxonomy, but it's not Bloom's. He basically, Fink basically thought maybe it should be significant learning. So he introduced a concept called significant learning, where this was 6 different aspects of learning was introduced. Foundational knowledge, which is, do they understand? And can you apply? So developing critical, creative, practical thinking. Can you integrate? This is where STEM comes in: information, perspective, people, life. This is fantastic that integration was there. Human dimension, learning about oneself. We forgot that. This is very, very important. Everybody is different. Everybody learns differently. Caring. The most important thing I enjoyed when I saw this framework the first time, you know, you need to develop something with new feelings, interests, and values, and then finally learning how to learn, becoming a better student. It's a very powerful thing. So I really enjoyed this more than the Bloom's taxonomy. The question is, how do you bring this in, especially for art education? Art education, this is used a lot. I know we talk about STEM, which is science, technology, engineering, mathematics, but expand that to the arts. This is one of the most popular taxonomies that's used in art education. So I engage you to think about Fink's taxonomy as well. And Fink's also came up with breakdown of action verbs on each one of these categories. So it is you can definitely Google and you can find a lot of great things. Now, let's talk about the 4 letters STEM. Let's start with S. So one of the most powerful methods in S is the scientific method. So the scientific method, essentially, as you all know, is multi-step method, and it was a problem-solving framework where you start with a hypothesis. So essentially, you make observations first, and then you come up with a hypothesis, like we did, if this, then that, and so on. Okay, and essentially, it's an empirical method. For acquiring knowledge. This was used since the 17th century, and it goes back. And so after careful observation, rigorous skepticism and assumptions and all that, you make a hypothesis using some inductive reasoning. And then you test the hypothesis through some experiments. And that's the whole idea. So that's a cycle. You create a theory, and then you want to see if it matches the original observation. So for example like this, you may start with an observation. You want to check, which fertilizer is the best. So that's your question. So you start with an observation. Your plant is not growing really well. You start with a question. You go to the market, and there's 3 types of fertilizers. You want to know which one is the best. And so you just test it out. You test that on 3 different plants, A, B, C. And so A grows really well. And then you say, oh, so you make a hypothesis. Looks like, maybe C is very cheap and B is a little more costlier, but A is really costly. So you start to wonder, why is this fertilizer costlier than this? Maybe it helps my plant grow. So you say, if I put fertilizer A, then my plant will grow very well. And that's your hypothesis. And sure enough, it grows well. But then it has the challenge that it's costly. That's another problem to solve. But that's how you do the scientific method as a kid. But then you can actually expand this even further. Let's go to the T. Now for the T, let me give you a framework. So for the S, I gave you a framework, scientific method. For the T, there's a wonderful framework called SAMR. SAMR stands for substitution is the very first step. So first think about no tech. That means paper and pencil. A substitution is, can you replace paper and pencil by something as a substitute? So take your traditional activities in the classroom. Can you substitute by something? I'll give you an example in just a second. And then can you augment it? That's the A. That is, can you use technology as an augmentation to the substitution? So here, there is no functional change on what you were doing before. Let me give you an example. You give everybody an essay to write, all the students an essay to write. That's a no-tech, paper and pencil. Now, substitution would be, let me ask all the students to write using Word document. That's a substitution. Essentially, there is no functional change in your process or in the assignment you gave. The students are just using Word rather than writing it on paper. Augmentation is you make an improvement to the function. You say, oh, why don't I upgrade it to a Google document? So now that you upgrade it to a Google document, then it allows you to modify, because now Caroline can work on the same Google document. I can work on the same Google document. Ronald can work on the same Google document. Now we are collaborating. So what you just did was you augmented some big idea and modified it so that we can actually, add. So modify, you can actually add some links to it inside that. And then you redefine it. So maybe the essay is so powerful that the students are going to add graphics, and then they're going to tell a story through a video and things like that. So that is how you use technology. This is ICT. And so the first two parts is called enhancement. The next two parts is called transformation. Can this be used in other subjects than technology? Yes. So the S is where you need to ask the question, what will I gain by replacing with the technology? And then you need to ask, what is the additional function that you're adding? That's the augmentation. Then the next thing is, what is the change, significant change I made here? The fourth one is, what did I create here? Okay. Let me just take, if it is okay, just 10 more minutes and finish my thoughts here. So an example in a history lesson, not even a science or mathematics, in a history lesson, students can write with paper, using Microsoft Word. So from paper, they upgrade to Microsoft Word. Then augmentation, they could maybe use like grammar checking and things like that. Modification, they could take it to, other related tools, maybe Google Docs, and then they can create a video about that history lesson. Or a geography lesson. So they could present using, for example, a PowerPoint. And then they can upgrade the PowerPoint with audio and video. That's augmentation. And then they can actually use like that to create brochures. That is modification. And then they can use Google Earth to show off their work. And that would be redefinition. So David has a very interesting idea. Thing saying most schools don't. That's exactly right, David. But if we are creative, we don't need technology to do these things. You can just use paper and pencil and augment it. You could have students sitting separately and working on an essay, and then ask them to come together, sit next to each other, and criticize each other's essay. You just augmented. So without using technology, we just upgraded their their work. So sometimes we just have to be creative in how we are using these frameworks. Exactly right. Just because it says technology framework, don't think it has to be technology. Okay. So yes. Very good point Caroline is making, because many ministries, I went and when I said I'm here for a technology training, they all said, are you going to teach me Word? Are you going to teach me Excel? I said, no. I will teach you all those. But above that, I want to teach you frameworks. It's very important to understand how to use technology in the classroom. Otherwise, you will be doing a bad job at not helping the students learn. Okay. So, I'm going to leave this activity, and Ronald and others can follow up. I would like everybody to take one of their lesson plans and actually create this one. I do it with all my teachers, and I actually have them create, how do you substitute? So take your own lesson, mathematics or whatever it is, and create an SAMR framework. And I'd like to see that at some point, and maybe you can give it to Ronald and Stephen, and then we'll see how you guys come up with some brilliant ideas on this. And then maybe on the right side, Ronald and others will comment, this is a good idea. Maybe you can try this. So this is the sheet I use with my teachers, or I give it to ministry when I do training and all that stuff. E, a very powerful technique that is missed in all other techniques is the engineering process. The engineering process is something very powerful because you go through a cycle called it's mostly like the others. You ask a question, you research the problem, you imagine a solution. This is a very interesting idea in engineering. They can make up all sorts of things. And then you make a plan and you create a prototype, another very engineering design where they build something. They test it, and then they improve. Another important engineering part is basically do an iterative design. So another powerful thing that is usually done in an engineering process. So which is different, a little different from the scientific method or the SAMR, but it's very, very interesting. So I don't have time today because to play this video because it's a very interesting 2-minute video. I don't know, Stephen, do we have time to watch a 2-minute video? And then I have maybe a few more slides. Is that okay? Like, can I take 5 or 10 minutes? Okay.
Yes, it's okay, Professor.
Okay. So I will play this video because it's a very powerful video. I want you to watch this. And if you can, I'm going to stop share for a second, and I'm going to share again, but this time with sound so that you can hear my sound also. And I'm going to play this. It's on YouTube, and
the engineering design process is a lot like making tacos. Here's how. Let's say you've had a long day. Maybe you've gone to class. Maybe you just got off work. Maybe you just finished an intense workout session. It's now 7 o'clock and you're hungry, but you've got friends coming over in half an hour. So what do? You go through the engineering design process. First, you define a problem or need. In this case, the problem is you're hungry and you've got people coming over in half an hour, and they might be hungry too. Next, you do some research to figure out the design requirements and your limitations. So in this case, you'd assess things like ingredients you have at hand, money you've got to spend, how much time you have before people start showing up, how many people you have to feed, and if any of those people have dietary restrictions. Once you've got a pretty solid list of criteria and constraints, you can start brainstorming ideas for solutions. Maybe you look online at nearby food options. Then, maybe you go to the fridge and you start figuring out what you could make. You weigh your options and you determine making something at home will be cheaper and faster than ordering something online. And you decide everyone likes PB&J, but you don't have gluten-free bread.
Oh.
But you do have corn tortillas.
I guess I'll try PB&J on corn tortillas.
And you make a prototype. You test it out and take a bite. It's gross. But you want to make sure it's not just you, so you get others to test it out, like your roommates or family. Everyone agrees. It's gross. You ask questions and determine what's gross about it. In this case, your testers like the tortillas, but not so much the PB&J. So you go back to the kitchen and reassess. This is what engineers call iterating, making changes based on test and user feedback. You realize,
I've got ingredients for tacos? Dope!
So you start making some veggie tacos. You try one and think,
This is kind of dry.
You have other people try it to get their feedback. Most people agree.
It's kind of dry.
So you go back to your kitchen and start iterating again. You find that you've got the ingredients to make guacamole. You make the guac and you add it to the tacos. You test it out and you're like,
This is tasting pretty good.
but some of the other testers think,
It could use some spice.
so you evaluate their feedback, you look in your kitchen, and you realize you don't have anything spicy. That's when you call your friend Sam who's coming over. And you're like,
Hey Sam, can you bring over some hot sauce? I'm making tacos.
and Sam's like,
Sure.
also,
I love tacos.
it's now 7:30 and your friends start showing up. You tell your friends,
I made tacos if you're hungry. You can add hot sauce if you want.
and then you and your friends eat the tacos. They're like,
These are pretty good. I'm going to Instagram that.
You should share the recipe online.
so you do. You've solved your hunger problem and engineered a taco party.
So it's a very powerful example of how do you make tacos or rotis, or or a food item, and it brings it out very well in this example. I hope you all recognize the power of engineering design process, where you go through an iterative process, and I know there is some side discussion going on the chat. So let me finish and then you can have your side discussions. So last one is M, which is my favorite, which is the mathematical modeling. So where we have to go from asking in mathematics, when children were asked, what is 2 + 3? That's a math problem. Now you could turn that into, if you have 2 apples and 3 apples, how many apples do you have? Like when children are growing, they're making sense of these numbers and you're asking an English question. Now, what if I just told you that I want you to bring apples to my entire class? So what exactly do you think this problem at the very end is asking, and which is not there in the previous problems? So in the previous problems, it was more concrete. You're saying specifically 2 apples and 3 apples. But when I throw a question like how many apples do you need for the entire class, what all are the questions that you need to ask? You need to ask, how many kids are in my class? How many kids like apples? How many kids don't like apples? How many people like green apples versus, which apples? Is it the red apples? So what happens is, before you do the math, you have to do a lot of understanding of data collection. So what happened was, a simple 2 plus 3 now has become much more interesting. This is called mathematical modeling, where you observe, just like the other scientific method. You come up with a theory, maybe an equation, you formulate, and then you do some analysis, then you do some simulation, you validate it, and then you predict it and see if it works. So all these models that I presented have similar frameworks. So this idea of inquiry-based learning is very, very important in all these things. So they all have a similarity, and they all have differences also. For example, the iterative design of engineering and the hypothesis of a scientific method. There are some unique parts to each one of them, but it is also important for these different frameworks. And I want to finish with this last framework, which is called TPACK. And TPACK stands for Technology, Pedagogical, and Content Knowledge. So imagine you have 3 Venn diagrams, and one Venn diagram is 1 circle, 3 circles as a Venn diagram. Imagine 1 circle is for technology, 1 circle is for pedagogy, and 1 circle is for content. Now, the area where technology and the content knowledge overlap is called TCK. The technology part only is called TK. The content knowledge, the blue part, is only CK, and the yellow part is PK. Now, when you have, yes, of course, I'll teach a whole course, Ronald. This is just the basics I'm teaching. I actually do this as a full course. So between content knowledge and technology knowledge is TCK. Between pedagogical is PCK, and then this is TPK, and in the center is TPACK. Now the question is, are your lessons good enough to be a TPACK? So essentially, if I'm teaching a course on a lesson on cell anatomy, what's the technology using? Well, again, it's not Word or Excel. It's the microscope that you're using. That is technology. What is the pedagogy that you're using? Well, the kids need to know about cells, some idea that body, and so you could make them talk together. Maybe you show a picture and do notice and wonder. What is the CK? Well, you ask them about, what do you know what a nucleus is? Do you know what this thing is? And so you ask those different type of things. So Caroline, super point. I see this repeatedly in several countries. CK, content knowledge, is all most teachers are teaching. They forget about the pedagogical knowledge. They forget about this, and they forget about mixing the two. So almost none. You're totally right. This is not just Uganda. It's the same in India. It's the same in South America. I've been seeing this. I've been helping ministries to really think about lesson plans. So same in the US also. So C is all about content. It's the what. What are you teaching? But you don't just teach the what. It's also the how you teach it, which is the pedagogical move that you need to group discussion, pair share, graphical organization, inquiry, debate, direct instruction, and then technology as a partner, like the SAMR that I was telling you about, right? So it's very, very important that, even in mathematics, you can bring this TPACK. In fact, this was popularized by mathematicians, by the way. So how do you bring technology, videos, iPad, camera? How do you take it to the next one, smart boards and things like that? And then when you bring it together, it's the sweet spot, which is the TPACK. So you could think about the commonalities between the two, the differences between the two. Here is an example. Google Docs, for example, is a TPK, where you're making students work in pairs. That's the pedagogical move. But then you're making them use Google Docs. That's actually a TPK. And PCK will be like, asking essential questions, notice and wonder, but you're also asking very specific math questions, let's say, so that forms a hook for the teaching. And so this is a very important project-based learning task. You need to be able to use TPACK. And how do I use this with my teachers? I give them a board like this, and I will work with Ronald later on. And I ask every teacher to name their lesson plan. I ask them to identify the TK in their lesson, the PK in their lesson, the CK in their lesson, the TCK, the PCK, and TPK. And many, many teachers struggle with this thing. I can tell you, many of you will struggle with this. And how do you enhance your lesson? This is going back to my original comment of how do you reskill yourself? Please reskill yourself by taking a lesson plan and try to see if you can upgrade yourself by filling this table. Now, finally, I want to close the loop. I'm going to come back to this later on, and we can finish. I will let you do this and finish this. What did you learn today? But after I do this, I'm going to show you my friend, Mr. ChatGPT, and that will be the last thing I wanted to show you today. So let me bring my friend ChatGPT on the screen here. So can everybody, so it's very easy to just, if you go to Google, I want to just make sure that you're all seeing my ChatGPT screen. My Google screen. Can you say yes if you're seeing my Google screen for a second on the chat, please? Can you say yes on the chat? So if I know that you're all seeing my screen. Yes. Okay. So I'm going to show you how ChatGPT works. So I'm just going to click on Google and say ChatGPT. I'm going to open ChatGPT. If you have a Google account, Gmail account, you can open it. So you get a screen and all that stuff. On the bottom, there is a send a message. So I'm going to send a message. I'm going to tell ChatGPT to create a lesson plan on to learn about a cell. Okay, so a cell biology lesson. I'm going to just click start, and within seconds, it's creating a lesson right here. You're seeing on screen wonderful lessons, middle school lesson. Students will do this, whiteboard, materials needed, objective, introduction to cells, 5E method. Notice it's using the 5E fantastically. And types of cells, again, it's using 5E. Specialized cells, again, it's using 5E. And cell disorders. So it's teaching everything about cells, and it just created an entire lesson plan for you and for grade 6 through this thing. And it tells you it's a 45-minute lesson, and it tells you exactly how to teach and all that stuff. Now, but I want to make this lesson a little better. So I'm going to say, create a lesson plan on about a cell using the scientific method. So I am making ChatGPT better, making me better lessons. I'm clicking on it now. Watch ChatGPT right now. And ChatGPT is actually creating it right here. And it's right there. It's already creating the lesson. But this time, what you're going to notice is a scientific method lesson investigation. So what you will see that it is going to be very clever. It has the materials. It tells you exactly, but it says introduction and all that stuff. Objective. Objective is the word from the scientific method. And then day 2, it says formulate hypothesis. It's actually going through the scientific method. Now, those of you that say it's a danger, it's actually unfortunate that you're thinking that way, which is okay. It is about, the third one is conducting experiments. The fourth one is data. Yes, you may think like people will cheat. That's completely okay. I will tell you what my final exam this year was. It is people, some of the educators here may think it's very dangerous, but let me also tell you, people use, students started to cheat. So what did I do for my final exam? My final exam was very simple this year. My final exam was, I asked students to use ChatGPT to give me an answer, and I asked them to give me an answer, and I asked them to put 2 answers next to each other, the ChatGPT answer and their answer, and I asked them to compare who's the best. And you know what? The students took it as a challenge and fought against the ChatGPT's answer. So please do not think ChatGPT is bad. You just need to take advantage of how to be creative with it. Okay? I will stop there, and I hope today's session was helpful to you as last time. And I'm going to just say bye to my friend ChatGPT, and then I will put this on the screen again. Anybody that wants to get in touch and all that stuff, feel free to get in touch. And I will stop here, Stephen. Thank you very much again.
Thank you, Professor Padhu.
Thank you.
I must say it's been learning and learning and learning. No wonder I put that comment that we need a whole course on frameworks, because
the whole course, Ronald. It's an entire course.
I think it is what we need. Friends, I'm sure you have some questions for Professor, or you may want to ask Professor to say something more about something. That would be good. Professor, you can now look into the chat.
Yeah, there's a lot
apart from the thank yous, there could be questions, friends. There could be questions. Please, if you have anything you would like, Professor.
Yeah. My purpose was to introduce some pedagogical concepts like Notice and Wonder, KWL. Hopefully you will use that in the classroom. Some frameworks like scientific method, mathematical modeling, SAMR, engineering design. Hopefully you like the engineering design process, the whole iterative thing and all that stuff. And, and then technology tools, right? So those are the main ideas and all that stuff. So.
I like the fact that you are using very simple examples to explain the models. And that's why I really hope that we shall get chance to go through them.
Absolutely.
Members, even before Professor comes back, I think we need to find that time to just go through some two models and then another two sometime. We will watch the video over and over again. But somebody says, Caroline says something, Professor.
Yeah, saying that's a good question. KWL is a framework where you are getting input as text from people. And mind map is very similar, except mind map is more visual. So we'll actually draw next time, since you brought mind map, next session, I will do a mind map. I'll show a technology on how to do it and all that stuff. So the mind map is fantastic to actually build, and we'll build a mind map next time.
Professor, probably you can read down the chats are coming.
Yeah, okay. Well, I'm actually impressed with your hub model where you have people at different places, and hopefully the learning continues to spread all across. So. And all these sessions I'm giving, as Ronald said, you can spend a whole course on frameworks because it has to be a course. If you really want to go in and create lesson plans and go and upgrade your lessons and all that stuff, try it with students and then come back and refine it. That's a whole course. So we'll have to think of maybe certain modules that you do, and then collectively, once you finish these modules, you get a certification from the ministry and things like that. So we should, Caroline, Ronald, we should talk later about this. So.
Probably, Professor, do you remember that video you played? Is it possible to talk through the different parts of the video, or to?
I'm going to send it to, I'm going to put it on the chat. So why don't everybody see it later on at their house and all that stuff. So I put it on the chat.
Okay.
So you can click on it and then you can watch it later. So you will go through the nice design process. Engineering, it's fantastic because engineers like to, unlike science and other mathematics and all that, engineers like to build little bridges and then they break it. And then they build better bridges, stronger bridges. So they have this design-based thinking. But scientists are more inquiry-based. They ask a lot of questions. You don't break a microscope, all right? So it's basically a fine difference between how scientists think and how engineers think. Inquiry-based versus design-based. But we need both. We need both. And Carolyn, I saw that you seem to like Fink taxonomy. You're right that you can bring formative and summative assessment into it very nicely, especially the caring part. I mean, it's very nicely done. Maybe it's a mix of Bloom's and Fink that we need actually. So. Great.
Okay.
So we can go ahead and stop today, Ronald, and I have to go also in 4 minutes. So.
Okay, so Professor, we would like to thank you so much, but I will ask Caroline, if you can hear me, Caroline, I know would have asked someone else to do it. Maybe Birungi Jacqueline, can you, Mr. Kaziva, can we make Birungi Jacqueline a co-host? Is it possible? Birungi Jacqueline, could you please move a vote of thanks to Professor for today? Birungi Jacqueline, can you open your microphone?
Yes, members, good afternoon, all of you. I'm grateful for our professor and the teachers at large. Me, I'm an ECD teacher who worked before, but I'm now a migrant in Middle East. I try to admire these systems in Middle East, which are really grateful. They are really grateful with our workers who are coming to work in the Middle East because they know we are good. But with computer, we will find that people are losing jobs because they don't know computer systems. And this is great for the Ministry of Education to put it in our systems and also to welcome it in Africa at large. And I'm grateful for this work. Thank you, members.
Okay. Thank you, Professor. The impact is great. You can hear that even some people are joining us from outside Uganda, and that is great. I want to thank you for the time you've given us. Dear colleagues, I suggest that we continue talking, but for me, I think we need to agree in 2 weeks' time on 17th, Thursday, we meet again at 2 p.m. and go through at least 2 frameworks. Let us all listen in the videos. Let us replay the professor's video and let us come back on 17th at 2 p.m. and talk through at least 2 frameworks before we meet Professor again in September. Professor, it's been a great time having you. And on behalf of all the Ugandans, all the teachers, all the administrators online, I would like to thank you for the time you are giving us, and we will be able to share this experience with the rest of the teachers, but also with the rest of the administrators and the officials here at the ministry. It's really great. It sits within our new curriculum, and it gives us the power to move on with the new curriculum. With that, ladies and gentlemen, I want to thank you for your time and wish you a great afternoon. Do not forget that at 4:30, we are starting on the biology lesson for Senior 4. And Mr. Kaziba, if you're online, you can also remind us about what we expect for A-level this afternoon. But Professor, we'd like to allow you to leave.
Thank you. Thank you. Bye,
Thank
everyone.
you, Professor.
Bye.
Bye, Professor. Mr. Kaziba, what do we have this afternoon and tomorrow?
Today afternoon, we shall have biology facilitation by teacher Arthur Kukonza at 4:30, and then we shall have the ICT for Senior 6. It will be still at the same time at 4:30. So this link we are on is going to be for Senior 4, but then we shall share the one of Senior 6 at 4:30. And today we shall be dealing mainly with database and spreadsheet in ICT. Then tomorrow we shall have ICT for Senior 4. We shall have both the practical and a theory paper. And then we shall also have applied mathematics session tomorrow. That is for A-level, still in that same room, A-level.
Okay, thank you, Mr. Kaziva. Ladies and gentlemen, we just want to let you know that we've had 2 weeks of hard work for the candidates, and I want to thank all the teachers who have been coming online and teaching, and we have demonstrated that we can close the learning gap. And going into the new curriculum, we can now do things differently. We can learn together. You can see, Professor was teaching us frameworks. We need to all learn these frameworks. And you might be the trainer for your district. We should be moving forward to create trainers for districts such that when there is an effort to train other teachers, we have somebody in the different districts to support the other teachers on some of these things we are learning. I know we are going to have a discussion with Caroline Sesemat. This is what I've been yearning for, that we do move into the space of the new curriculum with the integration of technology, such that it is very clear that all our colleagues learn together and they learn the same thing. With that, I want to thank all of you for joining, and I would like to say that this meeting is now closed until 4:30 when we get to the candidates session. Bye-bye.
Yeah, thank you so much, Mr. Ronald. Maybe the last one. Tomorrow we shall also have the digital change agents meeting at 2. Thank you. Bye-bye.